Okay, so let's take a look. For this one, we got vertical asymptotes, x-intercepts, and a y-intercept. And then we're trying to write a rational function. So if you remember back to the notes, in terms of a rational function, its x-intercepts are on top and vertical asymptotes are in the denominator. So as we factor and set things to zero, it's the numerator that's giving us our x-intercepts, and it's the denominator that's giving us vertical asymptotes. So we'll use that with these intercepts and asymptotes to kind of get the basic version of this thing set up. So let's go y equals, and then we're going to have some constant. It's that stretch factor that we've seen for all of our transformations that we don't know, and that's where this y-intercept is going to come in. So right now I'm just going to put an a out there as the constant that I do not know, and it is going to be times the things that are going to give us our x-intercept. So in this case, we have an x-intercept at 2, so that must mean we have a factor of x minus 2 to create an intercept at 2. And then we'd have to have another one at -4, so we'd have to have an x plus 4 up here, so that when I set that equal to 0 and solved, I would end up with an intercept there at -4. And then for that same logic for the vertical asymptotes, if I have an x-intercept at a vertical asymptote at x equals -5, then I'll have a factor down here of x plus 5. Because now if I look at that and I go, what are my vertical asymptotes? I know I'm going to have one at -5, and then x equals -1, so that must mean I have an x plus 1 up here, or down here, to produce that vertical asymptote. So super important, x-intercepts in the numerator, and then vertical asymptotes come from the denominator. And that gets you a good ways there. That took care of all of the information we were given except for that y-intercept. And here's where that comes in. So much the same, we did this with the polynomial ones too, where we did this constant and set up our factors and then had to solve for the stretch. That's exactly what we're doing in this chapter as well. I think that was in 7.2, if I remember right. It's in the 7s, but it's the same process. So I know that I have a y-intercept at 0, 5. So that means that 0, 5, I have and it doesn't have to be a y-intercept, it just has to be a point that satisfies this equation. This is just a nice one. What that does is it gives me an x and a y, so I can plug in for all these x's and the y, and that's going to let me solve for the stretch in front. So let's see where it goes. We got a 5 for a y, a, and it's nice that it's 0 because that's going to just make all those x's drop out. So this will be a -2, a +4, and a 5, and a 1. So cleaning that up top, I'm going to have -8, I'm just going to call it -8/5 right there, times the a, which is in the numerator. You could write it 8a up top if you liked to. And then I just have to get that a by itself, so let's multiply it by the reciprocal of that fraction. So we're going to go like this, and we'll go -5/8, and that will let me isolate a. What I do on this side, I of course have to do over here. So -5/8, and that will be a -25/8 equals a. So our final on that is going to look like y equals, how do they write these? Yeah, I think they just put it out in front. So -25/8, and this can all be the same fraction, and then we just got to put our factors back in there. So x minus 2, x plus 4, x plus 5, and x plus 1. And that should be it. And so then just to kind of look at this backwards, if we looked at this and said, what are our x-intercepts? X-intercepts from the numerators, they'd be at 2 and -4, which is exactly what our prompts are. Vertical asymptotes would be at -5 and -1. That's just what our prompts are. And if you let, not that I'm suggesting you do it, but if you put the x equals 0 back in there, you'll get the y-intercept of 5. But that's basically how all of these go, is you're setting up your numerator with the x-intercepts, the denominator with the vertical asymptotes, and then solving for that last constant using whatever point they give you. Cool, hopefully that helps.